Greetings of the day, dear students. Today, we are going to study about correlation and regression. As a part of the fourth unit, we will be initially going on with the meaning of correlation. So, what is correlation? So, basically, correlation analysis attempts to determine the degree of relationship between two variables. Now, this is a definition that is given by Yalun Cho, but what is the meaning of correlation? So it is a statistical technique which enables to measure the strength, degree, and direction of relationship or of covariance between two or more variables. In simple words, we are just seeing what is the degree of relationship with one variable in reference to another variable. For example, so just imagine one pen is actually costing 5 rupee to you. Now, if you want a second pen, you have to pay another 5 more rupee, that is 10. Now again, if you want a third pen, you will be actually again paying a one more 5 rupee, that will be summing up as 15 rupee, and the third pen will be coming in with the cost of 15 rupee. Now this is a positive correlation, which means when the price increases, the supply of the pen also is increasing along with that. So this is a kind of correlation as well. So basically, when we are talking about correlation, there is something called as positive and there are basically many types of correlation. As I was mentioning, there is positive and negative correlation is one type, and again we have other types such as simple and multiple correlation. We have partial and total correlation. We have linear and non-linear, as well as logical and illogical correlation. These notes I'll be forwarding it to you, so you don't have to worry much about that thing. So when we are talking about correlation, there are certain methods through which we are doing the correlation. The first one is through scatter diagrams, and the second one is Carl Pearson's correlation, and third one is Spearman's rank correlation as such. Scatter diagram is a completely theoretical aspect, and you don't have to worry much about that thing. It's like very logical thing. You don't have to worry much about that thing. But right now, what we are going to do is like we will be actually seeing what is Carl Pearson's correlation, and this is where we are actually doing giving our focus right now. Okay, so Carl Pearson's correlation is actually created in such a way that we are actually focusing much on the impact of positive and negative correlation. So whenever we are talking about Carl Pearson's correlation, understand this diagram. Okay, so this is where we are actually understanding what is a positive and negative correlation in detail. So according to Carl Pearson, the coefficient of correlation lies between two limits. The first one is plus one. This is the plus one, and the next one is negative one. So within this one and minus one, the correlation is actually lying when it comes to Carl Pearson's coefficient of correlation. And within these limits, the values of correlation is interpreted as we can see here. So between 1 and 0.75, we can see that there is a high degree of positive correlation, as you can see on the screen. Again, between 0.75 and 0.25, we can see that there is a moderate degree of positive correlation as well. And between 0.25 and 0, we can see that there is a low degree of positive correlation. And in when r is equal to 0, that means there is no correlation at all. So just understand that towards the right side, when the values are getting positive, it's always a positive correlation. And from 0 to 1, the correlation degree will be actually rising from low, moderate towards high. Okay, so that's about positive correlation. So you understood now what is positive correlation, right? Now, when we are talking about negative correlation is also similar to positive correlation, like we were mentioning. Between 0 and minus 0.25, we can see that there is a low degree of negative correlation. And between minus 0.25 and minus 0.75, there is a moderate degree of negative correlation. And between minus 0.75 and minus 1, we can see that there is a high degree of negative correlation. So just understand this diagram, always keep this in your mind, and just understand that the Carl Pearson's correlation is always focusing upon basically what we are seeing in this diagram, that is the relationship between plus 1 and minus 1, and the correlation lies between these values. So we are seeing whether it is a highly correlated, whether it is a moderately correlated, whether it is a positive correlated or negatively correlated, that we are seeing basically through this diagram. Okay, Now, moving forward with the same, we will be actually seeing what is a negative correlation, what is a positive correlation. Now you'll be having a doubt, right? So positive correlation is very simple. So just imagine, see the example here, increase in marks and time spent on studies. So basically, when you're actually spending your time more focusing on your studies, you can see that there is a positive correlation between the marks you are getting as well as the amount of time you are spending in front of the books or reading the books. So in front of the book doesn't give you any marks, but again, studying properly will give you marks, right? So the amount of time you're spending on these kind of things, on studies exclusively, is actually can be called as a positive correlation. The more you study, the more you will get marks. So it is a positive correlation example. Again, we have here negative correlation. Now, what is negative correlation? Negative correlation is also similar here. So price and demand, this is a classic example whenever we are talking about negative correlation. So whenever there is a negative correlation, if the price rises, the demand always decreases. You know that the same pen, just imagine the pen you are buying for 5 rupee, tomorrow it's actually just selling it for 10 rupee. Will you buy the same pen? No, the demand will fall down. Now that is where we can call as a negative correlation. Understood? So this is the example of what is positive and negative correlation. Now you can actually relate this also. So you'll be actually seeing whether the prices as well as various two variables. Just imagine the same example of marks and time spent is in the same graph. Okay, so you are spending almost like 5 hours on studies, and you can see that the marks you are getting on these 5 hours of studies will be either positively correlated or negatively correlated. So this is just an example I just told you. Now we will be going forward to the practical session. Okay, let's see what is the formula for Carl Pearson's correlation. That is R is equal to sigma xy by root of sigma x square into sigma y square. Now, this is the formula that I wrote in the notebook for you to understand easily. So now let's go directly into a problem and see how we are actually implementing this formula right into a problem and understanding what is the relationship between two variables. Okay, so here we have two variables in this question, that is coefficient, find the correlation coefficient between sales and advertising expenditure from the following data. So we are in this question we are seeing what is the relation of sales and advertising with each other. So we have values here, that is 65, 67 till 73 we have in case of sales, and in advertising we have from 67 to 70, right? So like we used to do earlier, we will be actually directly going to x and y directly. As you can see here, we will be actually taking the summation of x, that is 621. Okay, same way we are taking the summation of y as well, and we are getting 612. Now what is the first step here? The first step is to make the x bar as well as y bar. Okay, so now we will be finding x bar. So what is x bar? Sigma x by n. So what is the value of n? You can count the number of x values and y values, which will be 9. So sigma x is already given as 621, sigma y is already given as 612. Now let's directly go for x bar, where sigma x by n, that is 621 by 9, that will be 69, as you can see on the screen. Now again, what is the value of y bar? Sigma y 612, as we already mentioned. So 612 by 9, that is 68, right? Now what is the next step? Now when we got already x bar as well as y bar, what is the next step you can go forward with? The next step is to identify what is small x, that is x minus x bar. So what is the value of x here? What is the value of x you can see here? The x is this one, and what is the value of x bar? X bar is already, we understood that as 69, right? So 65 minus 69, what is the value? Minus 4, right? Same way again, we have 69 minus 66. In the second case, that is minus 3, right? So again, we have same way, we will be just getting all the values of small x here. Okay, so now we got all the values of small x here. Now what is the next step? We have to find what are y values. So what is the value of y here? Same way, like we used to do in case of x, we will be now having y. So what is the value of y bar? It is already considered as 68 here. So now we'll be going to y and we will be just doing the same. Here we can see the y values as y minus y bar, that is here 66 minus 68, that is minus 2 minus 1 minus 4 minus 1 again 3 1 2 0 and 2. So this is what we are getting as x and y here. Then once we are getting x and y here, what is the next step? Once we got x and we got y, now the next step is to just understand what is the value of x square. Now we already know what is the value of x here, that is minus 4. Small x is minus 4, then we will be squaring it, that is 4 minus 4 into minus 4, that is 16. So again we have the second one, minus 3 into minus 3, 9. So we will be getting x square as well, and we will be taking the summation of sigma small x square, that is as 60, as you can see. So that also we got. Now once we are done with that 60, what is the next step? Once we are done with the 60, what is the next step? We'll be going with the y square. In the y square, again, we already got the value small letter y as minus 2, minus 1, minus 4, minus 1, again 3, 1, 2, 0, and 2, as you already saw in the screen. Now we'll be squaring it and we'll be getting it as the summation as sigma y square as 40. Now we got x square, y square, small x and y, small x and small y. So all the values we got. Now we will be doing xy. Now instead of taking x square and xy, we will be directly going with the values of small x and small y. So we will be just multiplying these two and we will be going forward. Okay. So once we are going forward with this thing, the values will be minus 4 into minus 2, that will be 8. So minus 4 into minus 2 will be 8, as you can see in the screen. Then again we have minus 3 into minus 1 as 3. So same way like we used to do previously, small x into small y will be xy. So the summation of sigma xy is already taken and we got it as 33, as you can see here. So 33 also we got. Now what is the next step? The final step is to just put the whole thing into the formula, that is r is equal to sigma xy divided by root of sigma x square into sigma y square. So what is the value of sigma xy? It's already given as 33. So it will be written here as 33. Then again we already know what is the value of sigma x square and what is the value of sigma y square. So instead of considering any other value, we'll be just going directly to sigma x square. So what is the value of sigma x square? It is 60, as you can see. So 60 is taken in. Then again we have sigma y square's value as 40, so that 40 is also taken in here. Now again we will be just doing the calculations and you can see 60 into 40 is 2500 and 33 divided by root of 2400. The value of say will be coming as 0.6736, right? So once all these things are done, let's understand the same way like we used to do previously. Let's see what is the value here, 0.6736. So where is the 0.6736 lying in that diagram that we actually saw previously? See, where is 0.6736 will be lying? It will be between 0.25 as well as between 0.75, right? So once it is lying in between 0.25 and 0.75, what is the meaning of that? It means it is actually moderate degree of positive correlation is expected in that value, right? So here we can see that a moderate degree of positive correlation is applicable in that. So that is the whole sum done. Okay, so that's all about how we are doing correlation under Carl Pearson's correlation method. Another sum. Okay. Let's see what is the coefficient correlation when it comes to Carl Pearson method in the same sum here. That is x and y is already given on the screen. That is 10, 12, 11, 13, 12, 14, 9, 12, 14, 13, and y is also given here. So what is the first step we have to do? We have to identify what is the sigma x here. So sigma x will be is equal to 120 when you do up the sums. Then again we can see what is the value of y here. So again we have to do the sigma y as well here as, and we will be getting a value that is 100. Okay, So once we are done with this step, what is the next one? We have to identify what is a x small x. Okay, that is x minus x bar. So to identify what is the x bar, what is the step we have to do? We have to identify what is x bar. So for that, x bar is equal to sigma x by n. So sigma x is already considered as 120 divided by what is the value of n here? N is 10. You are just counting the total number of x here, so that is 10. So the value of x bar will be 12, as you can see here. Okay, so it's already given as 12. Now you can actually calculate what is the value of small x here. So what is 12 minus 10? Sorry, 10 minus 12, that is minus 2. Then we can have, same way we'll be doing, 12 minus 12 will be 0. Then we can have 11 minus 12, that is minus 1. Then we'll be continuing the same procedure, 1 0 2 minus 3, ignore the handwriting, 0 2 and 1. Okay, so that's all about small x. Now the same way we'll be doing the deviation from y as well. Okay, so we'll be going with the small y, that is y minus y bar. Okay, so now let's see what is the value of y bar. So y bar is equal to sigma y by n. So sigma y by n will be 100 divided by 10. So it will be 10. So once it is done, you can see that small y will be 7 minus 10, that is minus 3. Same way we'll be going forward, minus 1, then we have 2, then again we have minus 1, then we have 3, then we have minus 2, then again we have 0, 2, minus 3 and 3. I'm sorry, the order is maybe a bit confusing, but understand the essence of the whole thing. Okay, so then we could identify y as well, small y as well. Now let's see what is the value of xy, sorry, yeah, x into y. Let's see first. We could either go for x square or y square, but now let's go with xy for the time being. So x into y, what is the value of x into y? Minus 2 into minus 3, that will be 6. Same way, 0 into minus 1, 0. I'll be just doing the sums, just do the calculation by yourself. Minus 2 we have, then again we have minus 1, then we have 0, then we have 4, 0, 0, minus 6, then we have 3. Now once we are done with xy, we have to go with the sigma xy, that is the summation of xy. I'm sorry, sigma xy, the value will be minus 4. Once you're done with the sum, you can get it. So the same way, now previously what was the step? Now we'll be going forward with the x square, right? X is already there, y is already there. Now we will be actually doing the squaring up of the same. So x square will be, what is the value of x square? 2 square, 4. Same way we'll be going forward, 0, 1, 1, 0, 4, 9, 0, 4 and 1. So the summation of sigma x square will be, summation of sigma x square will be 24, right? So this is x square. Now we will be seeing what is the value of y square. Okay, so what is y square? Y square will be here, the y square will be minus 3, the initial one, minus 3 into minus 3, that will be 9. Then again we have, um, 1, then we have 4, 1, 9, 4, 0, 4, 9 and 9. So you're done with y square. Now we will go with the sigma y square value, that is 50, right? So now you got already all the calculation that is supposed to be happening. Now you got x, you got y, you have small x, you have small y, you have xy, you have x square, as well as you have y square. Now this is the basic calculations you had to do. Now we will be just putting the whole thing into the formula. Okay, so what is the formula? R is equal to sigma small xy by root of sigma x square into sigma y square, right? So once you are just inculcating the same thing into the formula, you can, I'm sorry, I just wrote sigma xy. Okay, yeah. So we'll go forward now. So let's just put the whole thing into the formula now. So sigma xy, what is the value? Sigma x into sigma y, that is minus 4, as you can see. Then root of, what is the value? Sigma small x square, that is 24, into, what is the value? Sigma y square, that is 50, right? 24 into 50 will be 1000 root of, sorry, root of 1200, and you can do the calculations and you will be getting you'll be getting minus 0.115. Okay, so this is the basic calculations. These were very simple because you used to do it previously also, so there is no difficulty in this thing. Only thing is that you have to put the whole thing into this formula, and once you're done with it, you'll be getting as minus 0.115, right? So now see where exactly 0 point minus 0.115, where will it be lying? It will be between r is equal to 0 and r is equal to minus 0.25. And what is it? It means low degree of negative correlation, right? So we just have to write as there is a low degree of negative correlation at the end of the sum. Okay, so that's all about correlation when it comes to Carl Pearson's method. I hope you understood with the last problem, like how you're doing Carl Pearson's correlation coefficient. Um, so the last problem regarding how we are doing the correlation under Carl Pearson's method. So now we will be actually seeing one more method where it is not that important in the exam point of view, but for understanding purpose, I am just forwarding it to you. So just understand that whenever there is a problem, when we are actually seeing that whenever we were doing the mean here, so here we got the x bar and y bar as complete numbers, whole numbers 12 and 10, right? Just imagine what if that is a fraction. Just imagine if it is 12.5, the whole calculation will be difficult. Now just imagine it is 12,500 and there is a fraction between, that is 12,500 point something, and all. Just imagine that's a scenario. So it'd be so hard for you to do the calculation. So in these kind of like scenarios, you can't actually go forward with this kind of a formula. What you have to do is, like, you will have to go with something that is very different but easy as well. Just for understanding purpose, I'm telling it to you. So this is the formula right here that you can see here. This formula right here is the best one to handle such kind of a situation. That is, r is equal to n into sigma dx dy minus sigma dx into sigma dy whole divided by root of n sigma dx square minus sigma dx whole square, again root of into root of n into sigma d square y minus sigma dy whole square. Okay, so this is the formula you have to do. Don't get worried about the prolonged formula that is actually maybe possibly confusing you. No, it is very simple. Only thing is that you have to just get to know what is this thing. So like the same way, we'll be actually going forward and we'll be seeing what is it. So here again we have a scenario. See, calculate the correlation coefficient. X and y is already given. we'll be going forward the same way till x and y. But here we are not just going for any summation of sigma x, because we are actually taking assumed mean here, right? So what is assumed mean? Assumed mean is very simple. We are actually assuming one of the values of x as well as y as a mean instead of just calculating the mean. So usually we'll be taking the middlemost values as mean most of the time. So let's take 44 in case of x, and let's take 14 in case of y. So we are getting both these things here. So we will be just calculating dx initially. So what is dx? X minus 44. So x 44. So that we are taking in, and we'll be getting 38 minus 44 will be minus 6. Then again we have 4 minus 4 minus 2, like that we will be just going down, and we will be getting a summation of sigma dx, that will be 1. Okay, same way like we were doing dx, we will be now going forward with the dy, where y is already here. So y we will be just taking, and you already know what is the assume me here, that is 14, that is in the circle right over there. So we'll be taking 10 minus 14, that will be minus 4, then again 7, 1, like that we'll be getting, and we'll be just doing the summation of dy also, as we'll be getting the values 6. Now what is the next step? We'll be going forward with the dx square. Okay, so what is the next step of dx square? So we'll be just squaring the dx value. So minus 6 into minus 6, that will be 36. Here we'll be just doing that. Then again we'll be going forward with the minus 4 into minus 4 will be 16. Same way we'll be just squaring the same values, and we'll be doing the summation as well, and we'll be getting 113 here. Again we will be going for the squaring of dy, and we'll be getting 1649, and we also will be doing the summation of dy as well as 112. Hope you understood till here. Now what is the next step? We have to do the dx into dy. So we already know what is dx. I hope you already know what is dx. So here this is the dx, and here again you can see dy as well. So dx into dy we'll be doing, and right over here you can see the dx into dy will be doing, and you will be just putting the same thing here. So it will be minus 6 into minus 4 will be plus 24. Same way we'll be doing the whole process, and we'll be ending up with sigma dx dy as 23. Hope you understood till here. Now when we are going forward, now this is where the formula part comes in. So the same formula that I showed you here will be actually implemented here. So putting on the same formula out here. So what is n? What is the value of n here? It is 9, and sigma dx dy will be 23, as you can already see here. Then sigma dx will be 1, that will be here. Then again we will be having sigma dy as 6. So it's already kept in there. Now what is the value of n into, that is 9 into sigma dx square? What is the value of sigma dx square? It is 113, as you can already see here. So it's 113 minus sigma dx square. Now what is sigma dx square? Just understand that sigma dx square is outside of the bracket. Square is outside of the bracket, so we will be just having sigma dx, this sigma dx here, and that we will square it, and we'll be having 1 square. Same way we will be just continuing with the whole formula, and we will be having 9 into 112 minus 6 square as well. And once we are going forward with the calculations, you can see that we will end up in 207 minus 6 whole divided by root of 1016 into root of 972, and the final result will be r is equal to 0.2022. So today this is all about correlation under Carl Pearson's method. This is what I was talking about the whole time. So this is an example of how assumed mean will be actually inculcated into Pearson's correlation method. And before that, we saw what are the different methods through which we can go forward with the correlation. We saw another formula. And thank you for listening. Have a great day ahead. Thank you.